We present Shape2Vec, a method for generating semantically meaningful descriptors for 3D shapes, sketches, and images. This allows users to navigate online repositories consisting of multiple datasets and multiple modalities. Here is an example of a navigation system based on Shape2Vec. A user is able to search datasets using a variety of modalities. She can use a text query such as the word car. Shape2Vec also supports mesh-based queries. Here the user is using a model from a collection of aligned 3D models. But we are not limited to aligned models. We can use mesh queries from other 3D collections, in this case a collection of unaligned shapes. We also support sketch-based queries. Although sketches vary depending on the artist who drew them, we are still able to retrieve relevant results. Finally, the user is able to use an image in the search engine and see what objects are similar to it. In all these cases, the labels that are shown underneath the objects are there purely for information. They are not used in the search query. We want to generate 3D shape descriptors that fit into a semantic space. We first need to do some pre-processing. We must compute the shape's depth maps from multiple viewpoints, and we must also learn a vector representation of words. Then we proceed in two steps. We first learn to recognize depth map classes, and then we learn to generate, for a given depth map, a descriptor that is similar to its label vector representation in the semantic word space. Finally, we average the descriptors for all the depth maps into a single 3D shape descriptor in the semantic word vector space. We can learn a word vector space using a language model such as Word2Vec that learns word embeddings from unannotated text corpus. Here is a visualization of some word embeddings projected in 2D. Notice how similar concepts are grouped together, such as animals and vehicles. Given such a word vector space, we first train a classifier to learn visual features that aid classification. Next, the classifier is converted into a regressor that, for a given depth map, outputs a vector constrained to be near its class embedding. A training example consists of a depth map and the embedding of its label into the semantic word vector space. This learns semantically meaningful descriptors. Here are shapes from selected classes projected in 2D. Shapes from similar classes, such as chairs, tables, and armchairs, are grouped together. We can repeat this process for sketches and images. Shape2Vec supports cross-modal shape retrieval. Each row is an example of results arising from a different mode. From the top, a sketch, a word, a depth image, a natural image, and a 3D object. Finally, here is a user session where the user navigates the system with different modalities. The user is able to click on search terms and the system searches through the database to find relevant results. So the user has clicked on a word. Now the user will choose a model and the system will retrieve similar models. The user will then go and look for an image that they want to find similar models to. Because this is a semantic word vector space, the user is even able to search for objects that do not exist in the database. So guitars are a class that exists in the database and the system duly returns appropriate guitars. But there are no harmonicas in this database. But by searching for harmonica, objects that are similar semantically are discovered. and in this case the user decides that the closest thing is a piano. So Shape2Vec is the first method that is able to support a large number of modalities at once, and thus can enhance the search features in online 3D repositories. Thank you for listening.